Probability.
Probably.
Our learning target for today. I can analyze die rolls, spinner spins, and other events. I think I made up this last word. I'm not sure. Probabilistically.
Probabilistically.
I'm not sure if that's actually a word, but I think you probably know what I mean.
I want it to be.
All right.
It should be a word.
So I am going to do some review since we didn't record the lecture yesterday. We'll start with just the definition of what probability is, right? So the probability of any event A. Remember, we talked about the P parentheses is how we show probability of an event is equal to, I'm going to write this out, the total number of possible outcomes. That's our denominator. And then the number of desired outcomes. I'm not going to go too much into this since it is review, but it's always important to remember you can always find probability this way. So probability of rolling a 1 on a 6-sided die is 1 out of 6 possible outcomes. The probability of rolling a 5 on a 6-sided die is only 1 5, so that's 1 out of 6 possible outcomes. The probability of reaching into a bag full of all the letters in the alphabet and picking out the letter Z, only 1 Z, so that's 1 out of 26 possibilities. Right? So we can always find probability this way. Now sometimes it's going to be easier to use the additive rule or the multiplicative rule. Right? So the additive rule was if we want the probability of one event or another, that's the same thing as the probability of A plus the probability of B, where A and B are two different events. Now, there's something here that's really important to realize, which is it depends what we mean by or. Right? So what if I say I'm going to roll a dice 2 times? What's the probability that I roll a 1 the first time or the second time? And a key question about that is, when you say or, do you mean either or? Like only the first time or only the second time?
No, either.
Or do you just mean it could be on any of those times, the first, the second, or both? And so a lot of times you will see this rule written out with a minus at the end. You subtract the probability of A and B. So the probability of one event or another is the probability of one plus the probability of the other minus the probability that they both happen together. Right? So the probability that I roll a 1 would be 1 out of 6 plus 1 out of 6 minus 1 out of 36, because that's the chance that I roll a 1 on both dice. And we don't want to include that, because typically or means exclusive. And sometimes in math, you'll hear people talk about inclusive OR versus exclusive OR. An inclusive OR means it could happen both times, in which case we get rid of this. An exclusive OR means it has to only happen one time.
But would we, so what we did on the homework though, would it be right?
Yeah.
We would still get one.
Yeah. Alright. And then we have another rule. This is called the multiplicative rule. Probably has a more fancy name, but I don't know. Which says the probability of one event and another is the probability of the first event times the probability of the second. Alright. So we could go a little bit more into these rules actually. Like the additive rule, for everything that we've done so far, this explanation is fine. But there are certain cases where you have events that are not mutually exclusive. So we're kind of going to assume that our events are mutually exclusive. Mutually exclusive this means the probability of one does not impact the probability of another. So we're going to try to look at mostly mutually exclusive events. An example of an event that wouldn't be mutually exclusive is, let's say I said, reach into a bag that's full of all the letters in the alphabet. Right? Each one of those cards has a color, blue, red, or yellow. What is the possibility that you pull out a letter that is in Ben's name or the letter that is blue? Those things are not exclusive, right? The B might be blue. And so if I pull out a B, that's in Ben's name, but it's also blue. And that's again why that rule about subtracting the probabilities of both comes into play. We're not going to go into that in a lot of detail. Mostly we're going to look at events that are mutually exclusive. So the probability of one doesn't impact the probability of the other. Okay? And usually you can see by reading a question or by looking at it if the probabilities are mutually exclusive or not. Okay. Can I erase this? Another thing to remember about probabilities, the probability of any given event A is always greater than or equal to 0 and less than or equal to 1. And the 0 and the 1 are sort of special cases. A lot of times you'll see the probability of a null event is 0. What that means is if I'm rolling a die, I can't really think of an outcome with a probability of 0 unless it's not a possible outcome, right? What's the chance that I roll a 0 on a 6-sided die? Oh, 0. But that's not really an event. It doesn't happen. There is no 0 on a six-sided die. At the same time, a probability of 1, right, that's the same thing as saying 100% probability. That means you have all of the possible events. This is I've seen this written as like probability of t, where t is sort of the total, equals 1. So we know if the probability of something is 1, that is all of the possible outcomes. Right? What's the probability of rolling a number when you roll a six-sided die? 1, right? 100%. And you'll notice in math, like, we're not considering weird things that might happen, right? If we're talking about sort of real life, I guess there's a small chance that when you roll that six-sided die, you know, someone comes along and writes the letter A instead of the 1. But we're not including weird things like that when we talk about probabilities. And then the last thing that we talked about was the probability of event A plus, and this is written in two ways. Usually I see it written as A naught or A prime or whatever, equals 1. So the probability of A and the probability of not A added together has to be 1. Sometimes you'll see this as like negative A, but it's not really negative. It has like a little extra thing. Or I'll probably use this to mean not A. So the probability of something happening or not happening has to be 1. Right? And again, we're not doing the weird case where, okay, if I flip a coin, it either has to be heads or tails. It's not going to ever land on its side, right? Now, technically, there is a slight chance that it could possibly land on its side, but we're not going to consider that in this treatment of probability. All right. So the one kind of new thing I want to look at today is we can talk about probabilities as areas. And this is actually a really useful tool in math. So we imagine that the probability of any event, A, is sort of a circle. So the probability of picking out the letter B from a brown bag filled with letters, that's an area. Right? What's the probability of picking out the letter C from that bag? Well, I guess I should actually use the... What's the probability of picking out A? That's this area. Probability of picking out B is this area. Right? And when you start to visualize these as areas, this helps with two things. One, it can help you to see the larger picture. Okay, A plus B, I can see now that if I added those areas together, those are my chances of being here or in here. But this is really helpful when we talk about mutually exclusive events. Because in a mutually exclusive event, we have areas like this. If there's an event that's not mutually exclusive, we would have areas like this. They would overlap. Right? And this is where that second part of the rule that we talked about comes from. The probability of A plus the probability of B minus the probability of A and B. Is that right? I wonder if I'm using the wrong sign. So we have to subtract this because otherwise we'd be counting it twice. And this is what I mean by the probability of A. Now I'm questioning whether I'm using the right symbol. I can't remember if... I'll have to check. I will check for you. There's two symbols, right? One of them means and one of them means, oops, It's not actually a U. One of them means or. And now I'm doubting myself.
It's okay.
Alright, I'll check this. So sometimes drawing out the areas will help you see if an event is mutually exclusive, which helps you see, do I need to subtract this middle area or not? We have to subtract the chances of it. Alright. That is all. You guys have questions about any of that stuff?